Hello everyone, welcome back to the channel. In today's lesson, we are going to learn representations of sets, empty set, universal set, finite and infinite sets. So let's get started with an example. In this example, we are given a set A consisting of natural numbers smaller than 3. Let's determine the elements of a set A and also 3 natural numbers. So besides that, let's find 3 elements which do not belong to this set. So our set A consists 0, 1, and 2. Using membership notation, we can show this. 0 is an element of A, 1 is an element of A, and 2 is an element of set A. Now, as you can see, 4, 3, or 5 are not elements of a set A. So 3 is not an element of A, 4 is not an element of A, and goes on. Numbers greater than or equal to 3 do not belong to this set. Now let's see different representations of sets. Sets are commonly represented in 3 different ways. The first one is a roster method. In this representation method, all elements of a set are written inside curly brackets separated by commas. Before we write an example, let's write its definition. As we said, all elements of a set are written inside curly brackets separated by commas. This method is called roster method or roster representation. Now let's write an example. Let's get the set given above. So our set A contains 0, 1, and 2. Also, this is known as a list representation. Here we have curly brackets and all elements are separated by commas. This method is roster method. Second representation method is Venn diagram method. In this representation, the elements are shown inside a closed curve. This method is very useful for visualizing sets and their relationship. Let's show our set A given above in Venn diagram. Before we write an example, let's write its definition. Okay, let's show our set A given above in Venn diagram. So we have a set A and we have a closed curve as well. We write elements of A like this, dot 0, dot 1, and dot 2. This is Venn diagram method or Venn diagram representation. Our third method is set builder method. This method is generally used when the set has many elements. Instead of listing all elements one by one, we describe a common property. So, for example, our set A equals x's such that p of x. We write like this. Here elements are x's and we have constraint on x which is p of x. This is read as A is a set of all x such that p of x is true. That's right. Now let's give an example. Let's represent our set A given above with set builder method. Our set A was set which contains 3 natural numbers 0, 1, and 2. Here we can show this set, or we can represent this set as like this. A equals A contains x's such that x is smaller than 3 and x is an element of natural numbers. So this is another representation. Also, let's write another example. Let's say we have a set B which contains x's such that x is smaller than 2026, where x is a natural number. So this means B contains elements from 0 to 2025. Here we have 2026 elements, so it's really hard to write one by one. At this point, set builder method is really useful. Now let's move another topic. Now let's learn number of elements of a set. What is a number of elements of a set? Now, if we are given a set A which has n elements, we write this as S of A equal to n. Here n is the number of elements of set A. Also, we can use absolute value to represent the number of elements of a set A, and this is read as cardinality of A, which is equal to n. Some resources, it's represented as n of A, or denoted as n of A equal to n. All of these n's are the same thing, just their notations are different. Of course, here our n is an element of natural number set. Let's write an example. Notice carefully the sets inside the set we have. We have a set A, which contains 2A1, a set 3, 4, and a set C and B. We are asked S of A. We need to find value of S of A. So, as we said, we need to be careful. Here we have a set, and here we have another set. The set 3 and 4 and C, they are sets themselves, but also they are elements of a set A. So, this is first element, second, third, fourth, fifth, and sixth element. So, cardinality of A equals 6, or S of A equal to 6. Let's write another example. Here we are given a set A which contains k's such that k squared equals x, where k is a natural number, and x is between 9 and 65 here. So we are looking for the number of elements of a set A. In other words, we are looking the value of S of A. In this set, it represents perfect squares between 9 and 65 because it contains k's where k squared is between 9 and 65. If a perfect square is between 9 and 65, there are 16, 25, 36, 49, and 64. So we have 1, 2, 3, 4, 5 elements. Hence, we can conclude that S of A equal to 5. Now, let's see what an empty set is. Let's give its definition. Actually, in our previous videos about sets, we gave its definition. Here, let's say it in a proper way. Empty set is a set with no elements, and it is denoted by this symbol or these brackets, curly brackets. From the definition given above, we see that the cardinality of an empty set is 0. For example, if A is an empty set, then cardinality of A equals 0. Now let's solve an example related with all this. In the set A, we have a condition. By the way, A contains x's such that x squared smaller than x and x is a natural number. Here we have a condition on x which is given as an inequality. X squared smaller than x. Of course, x is a natural number. It is easy to see that there is no natural number whose square is less than that number itself. So inequality never holds for this x where x is a natural number. At this point, this implies our A is empty set because here we have no such x. Since A is an empty set, cardinality of A or S of A, number of elements in A, equal to 0. Now let's continue with another example. Now here we are given a set B which contains x's such that x is a negative prime number. We know that there is no negative prime number because primes are defined on natural numbers. For more on primes, you can watch our videos about primes on our YouTube channel. Since there is no negative primes, set B is an empty set as well. So let's write no negative prime, which implies our set B is an empty set. Since B is an empty set, cardinality of B or S of B equal to 0. Let's continue with example 9. Here we are given a set C which contains x's such that x squared plus 4 equal to 0 and x is an integer. And we are asked to find the value of S of C. Here we have a condition on x which is it satisfies the given equation here. So the equation is x squared plus 4 equal to 0. Also x is an integer. We know that there is no integer such that x squared equals to minus 4. We know that there is no such integer whose square is a negative number. Since there is no x, our set C is an empty set again, and S of C equals 0. Before we start new definition, let me write an important note. Let me put a star. If we see this or these sets, be careful that these sets are not empty. Each set contains one element. Here we have a set and it contains this symbol. And here we have another set and it contains this symbol. Of course, these are empty sets, but here we have another parenthesis outside of empty sets, which means the outside parenthesis contains empty sets as an element. So these sets are not empty sets. Now let's define universal set. Universal set is a largest set under consideration that contain all related sets. Let's write this. So universal set is generally denoted by the letter U. U is our universal set. We can think of like this. We have a universal set. This is its Venn diagram representation. Inside our set U, we have sets like A, maybe set B, maybe somewhere here we have set C. And here sets A, B, and C are subsets of our set U. And if A is a subset of U, then a union set U equal to U, and also A intersection U equal to A. These two are important, but we will focus on that later. After giving the definition of universal set, now let's see what is finite and what is infinite sets. Let me write its definition. Definition says that if the number of elements of a set can be expressed by a natural number, then the set is called a finite set. Otherwise, it's called an infinite set. For example, let's remember our example from above. Example, we have set A which contains 3 natural numbers 0, 1, and 2. Here, cardinality of A equal to 3. So we can say that set A is a finite set. Also, let's write set B, which contains even numbers. For example, let me start from 0, 2, 4, 6, 8, and goes. We cannot show cardinality of B, or we cannot express its cardinality by a natural number. So our set B is an infinite set. And also we have really known examples like natural numbers, integers, rational numbers, real numbers, and set of complex numbers are just some of them. I hope you enjoyed this lesson. If you enjoyed this lesson, don't forget to like the video, subscribe to the channel, and see you in the next math lesson. Thank you.